Hello everyone, I am Bibhorr, an aerospace engineer currently affiliated with IU, and I would be discussing the role of AI-powered autonomous avionics systems in interplanetary spaceflight. To begin with, let us see where all avionics systems help in spacecraft systems, and these are in managing the smaller systems within the spacecraft, be it display systems or power distribution systems, most significantly in navigation control, tracking, and communication with the base stations. Now the question comes, how is AI relevant in aerospace industry? While we are well aware of AI deployment across industries, especially in ICT, let us see where all within the aerospace sector can AI find its way. Right from material designing, structural analysis, to supply chain operations, space training programs, and needless to say, in development of aerospace software solutions for traffic disaster management, spaceport workload management, and more. Now comes present efforts of implementing AI in aerospace, with AI finding its way into every sphere and almost every industry. Present efforts of implementing AI in aerospace are limited to establishing enhanced aerial vehicles with new efficiency and capabilities, data extraction, simplification and pattern tracking in developing defense systems applications, and other process-oriented areas such as fleet management, manufacturing, and production processes. Now we'll discuss the future prospects of implementing AI in aerospace. Research is underway for deployment of AI in flight planning, flight performance optimization, predictive maintenance, pilot simulation trainings, aerospace designing, safety assessments, and conflict prediction. Space traffic management is the most focused area where AI would find massive application with swarm intelligence to mitigate space collisions, disasters, and manage space debris effectively in the future. The conglomerated model of AI, virtual reality, and machine learning would find its use specifically in space program simulations and pilot training programs, while at the same time in smart avionics dashboards, security management, service management, staff management, etc. Here are some brief insights on how AI in space traffic management would work, which is one of the key research areas. So here is the procedure: space tessellation mapping in the three-dimensionally dilated coordinate frame, identification of vehicular traffic as nodal flux, rendering of polygon configuration in 3D spatial cuboid, rendering of interspatial lines as relative distances, and then the rendering of interspatial angles as relative angular measures, fault correction, data gathering, and finalizing the triangulated mapping. Time metricized modeling of the mapped data, strategizing neighboring traffic movement, and finally adjusting overall traffic setting. This is how AI would be implemented in STM. Next is the role of AI in space emergency management. AI in space emergency management can help as below: identification of faults, disasters, or any space mission emergency, collection of enormous data to be put to action from all the prevalent resources, identification of the requirements and considerations, strategizing of the priority ranking, which one is to be considered first and which one is to be considered last, analyzing the possible outcomes within a minimum time window, and finally taking action accordingly based on all the AI inputs. Based on the similar lines of space traffic management, AI in space debris management will help in identification of space debris as nodal flux, smart mapping of polygon configurations in 3D spatial cuboid, identification of mutually established behaviors of the debris components, rendering of interspatial lines as continuously changing relative distances, rendering of interspatial angles as continuously changing relative angular measures, data gathering and finalizing the triangulated mapping, and then finally strategizing the disposal of the space debris components accordingly. Finally, we have summary here. AI, autonomous solutions, and swarm intelligence are the answer to many problems and risks associated with the growing human interest in space exploration. AI-based spacecrafts that could communicate with the nearby traffic would then be the need of the hour to prevent collisions and other space disasters. Integrated model of AI machine learning VR technology for simulations of space programs and dry runs can significantly help mitigate the risks associated with the entire space mission. There is no doubt that in order to minimize potential hazards and risks and negate any possible space disaster, AI is surely the way forward. With this, I conclude my presentation. For any further questions that you might have, please feel free to contact me on my email ID, that is bibhorr@zoho.com. Thank you. Cheers.